Alright, for this video we're going to be talking about three things. How I thought this worked before I got it, how I've seen it worked, and why I got this specific 3D printer. So let's get started. So before I got this 3D printer, I was almost certain about how it worked. I thought, alright, it just somehow goes layer by layer. I think I thought like you put a model into it, like you get a 3D model from the internet and you like download it to it, and then it just sort of cuts the model and creates it layer by layer. Really basic, just basically not even correct. And I also kind of thought that it wouldn't be really that complex, like there's not too many variables, it's just sort of like there's a quality adjuster and that's it. I didn't think about what kind of bed you'd be using. I didn't think about anything like that. But yeah, I also thought most 3D printers were expensive, like much more expensive than some of the lower stuff I've seen in the market. Like I thought they had to be at least $300. I also didn't think about what kind of different like filaments you'd be using. This is just what goes inside to make the plastic. I also didn't really think about how the fact that it would be plastic that's making most of your models, some variation of plastic. And I thought they were more complicated, like there'd be more parts to it and more like sort of stuff to make sure nothing went wrong, but it's much more simple than I thought. So now I'm going to talk about how I've seen it work. But before I get into any of that, let's talk about the parts and basics of a 3D printer. Alright, so firstly, you have your x-axis. That's the axis that this print head, well it's actually called the hot end, is moving on. You have your y-axis, and that's the direction that the print bed is currently moving on. You have your z-axis. It's basically up and down. Now, you've got your motors. There is one right there, and that's just to make it go up and down. That's a z-axis motor. And then, over there, real far, there's another motor, also a z-axis motor to make it go up and down. And then, you've got a y-axis motor right there. Here we have an x-axis motor. It just moves the print head or the hot end left and right. So this is an extruder. What happens is there's a motor right here, and this motor controls this gear. And these two gears right here are so close together with this filament in the middle that when they spin, they push the filament through. And so if I do it manually, you can see it spins. And that's how you get the filament over to your print head. And so now I'll demonstrate what it looks like when it's actually working. And then, after going down and around this tube, the filament comes out the hot end. This part, right here, which is what actually melts the filament, makes it ready to be 3D printed. So now I'm going to talk about how I've seen it work. So my original idea, like I said, was that I thought it just somehow went layer by layer and cut the model. That's actually slightly correct, although you don't do that in the printer. You have a thing that's called a slicing software on your computer. It takes a model from the internet, you download it, and it separates it into layers, and then it tells the printer what to do for each of those layers, and turns it into something your 3D printer can understand. Sort of like go to X coordinate this, Y coordinate this, and create a line. It's just extremely close to parts code. So like telling motors exactly what to do, very basic code. So in a slicing software, you can also make a thing called a raft. It's basically just sort of like a plate that goes underneath your 3D model. So if I get something real quick. So, well, instead of printing your model directly on this little bed, this is your model. It creates a small plastic plate, like typically I think like maybe a couple millimeters wide, and then you put that model on it, and it's much better because it sticks down to this layer of plastic a lot better. It's important because it makes it so that your model sticks down a lot better and is less likely to fall off or sort of start peeling up or anything like that. So a nice thin layer of plastic that goes underneath everything. Also in your slicing software, you can set your temperatures. So there's a little nozzle right there. I'm not sure if you can see it. I'll probably get into it later. But this nozzle has to reach a very high temperature, normally between like 190 to like 210 degrees Celsius in order to to melt this kind of plastic. It's called PLA. It's got a very specific melting point that you're supposed to use. So this little nozzle has to reach that temperature in order to make this stuff melt. And then you've got this bed down here. You want your model to not melt when it touches the bed, but also you don't want this bed to be really cold, because then it's not going to stick down really well. So you warm up this bed a little bit. Normally I like to do it to like 7 degrees Celsius. That's a little bit higher than some people go. A lot of people like to stick at like 60 degrees Celsius. And you can just basically do that in the printing software. You can also set up your speeds of different things in the slicing software. So like for instance, if I want the head, when it's going on the inside, just the inside of the model, if I want to go extremely fast on the inside but then slower on the outside, you can set that. And if I wanted it to go, I don't know, really, really fast when it's making that raft underneath everything, I can do that. I can set different parts at going different speeds. Really nice. And then it also can create supports. That's what your slicing software can also help with. I'll get into it later, but it basically can detect if your model is overhanging too much, if it's sort of going at like a really sharp angle, like if it's going like this, for instance. It'll automatically detect that and be like, oh, I need a support here, and it'll print a support. But we'll talk about that a lot more later. So, as I said, before I thought that it kind of just went layer by layer, which is sort of correct. The first layer might just be your raft or whatever, and that might be the first couple of layers. But as it actually starts printing the model, it can get a lot more complicated, because sometimes you'll need a thing called infill. So if I'm printing a cube, right, I don't want the entire cube to just be a solid chunk of this filament. I would rather it be pretty hollow, but still strong. And so I'll put up a picture of how you could print the inside of the cube tons of different ways. I think there's at least 7 different patterns, and you can just fill in a cube with all these different patterns as opposed to filling in the entire cube. That way, the cube is still strong, but you save a lot of plastic. And now we're going to talk about how when it's printing, it can make supports. So it just basically creates a sort of weak structure that is going to help later on in the print, because it'll make it so that you can print different things that are going out like this on top of those supports. So let's take this off for this part. I want to talk to you about my print bed. I really hope I don't have to auto level this again. That sucks. But here. So this might look like a really fancy, really cool print bed. What is this weird blue stuff that you got on your printer? It's a piece of glass with masking tape on it. It's really simple, and it's pretty cheap actually. But what's great about this is that it's a rough surface. So if I were to try printing on this metal or straight onto glass, there could be some problems because it's not really that rough. It doesn't grab the plastic per se. But this rough painter's tape, this rough masking tape, actually holds on. So the plastic can sort of adhere really nicely. And so that's just what you have to do. It's one of the many ways to create something known as bed adhesion. Bed adhesion is just trying to get your models to stick down on your bed. Bed adhesion, pretty simple. The other ways are kind of funny in my opinion. For instance, one thing you can do is you can actually take some glue sticks and rub it along where you're going to print, because glue stick, it's glue, so it'll stick down really nicely. And then you can also use hairspray, because if you spray it, the way hairspray works is it holds your hair together, and so it can actually hold your prints down too. There are some other methods that I can't really think of off the top of my head, but those are just a couple really popular ones. I personally am completely fine with just using masking tape. You just have to replace it when it gets all kind of messed up, because occasionally you'll have your print head sort of scrape, and you'll have it so that it kind of gets some plastic stuck on there, so you just got to replace it every now and then. So another thing is bed leveling. So if you notice these little knobs, this is actually an upgrade I printed, because the knobs they include are really small. If I can just move this a little bit, might be hard to see, but right there's a small knob, and you use those to make it so that the corners of this bed can go higher or lower. And so what you wanted is that the bed is really nice and level, because if it's level, then you won't have bad prints. So if I had a bed that was kind of going curved like this, the print might start off good here, but then it's kind of trying to print over here, but there's nothing. If it's even a little bit off, then you're printing off into nothing and it won't stick down correctly. Or you could have the reverse problem and it's starting down here, and then as it goes higher, it's running into the print bed, which is not fun. And a lot of problems that you'll have with 3D printing are just because your bed isn't leveled properly. It's highly important, especially because it can affect the first layer. So, first layer is one of the most important layers in 3D printing, because if you get that first layer wrong, you get all the other layers wrong. Mostly, depending on how bad you mess it up. Like for instance, if you had a huge bubble in your first layer, it's going to try to print over that bubble. It might go through it. You could have some issues there. But yeah, the first layer is one of the most important ones, because if you get that first layer to stick down, if you get it to be nice and even, if you get it so it's really looking clean, the rest of your layers can go really well. Oh yeah, so another thing you have to do with a 3D printer is to put in some filament. So it's pretty simple. Just you take your filament and you put it in. Typically they'll have instructions, you'll be able to find some videos online, but you just put it in there, and once you got it in, you gotta push it all the way through, and then you heat it up and you print. It's just a thing you gotta do. Eventually you will run out of filament and you just buy another one. And people like to think filament's pretty expensive, but it's really not. It kind of depends on, first off, the quality of the filament you're using and how often you use it. In the beginning when I got this thing, I would just run through filament. I would just abuse filament, basically, because first off, I would fail a lot of prints, and second off, I got a 3D printer. I was really excited. I still do use a lot of filament, but I don't know. For reference, you can print 1,000 grams of plastic, right, for about, like, I think $20 to $25 is a pretty good deal if you're printing about 1,000 grams of stuff. So that's just how much you get, and that's 2.2 pounds for you American folk. I'm an American folk too, so I don't know why I reference you guys like you were in the third person, like you're not me, but I am an American person.
Well, if you ask me where I come from, here's what I tell everyone.
I am an American person.
Dear Greece.
And for me, it took like 2 to 3 weeks to go through. Yeah, I think it was about 3 weeks for me to go through all of that filament. And I would fail constantly. So, it's a really good bang for your buck in my opinion. And so once you got your filament in and it's bed level and everything's working and all that, you can get a model from any site of your choosing. I like Thingiverse. It has a great set of, it's just all models, and it has pictures of people who created it, and it's got comments about it. It's just an amazing site. So after you download the model from Thingiverse, you gotta choose the settings that you slice it with. So the settings are highly crucial to the entire printing process. I mean, a difference in like 1 or 2 settings can make the entire difference between a working print and a non-working print. It's extremely important. You got yourself, your layer height, your supports, your infill, your bed adhesion, your speed, your materials. Materials is just temperature and such. It's just highly important that you have good settings. If you have really good settings, then you pretty much won't have very many failed prints. You also don't have to configure the settings all by yourself. What I did, because I'm a complete noob at 3D printing, is I would look up CR10 Cura settings, because Cura is my slicing software, and then I would just go on the first video that I found, and I would copy the settings exactly and try printing with them. Print something small, see how that works, and then scale it up once you good. And then I can tweak the settings a little bit if I find, oh, I want this to be different, or I don't like the way he made the supports, or whatever. You gotta have good settings. You don't have to create them all by yourself. Oh, and you can make profiles of settings. So let's say you really like this guy's settings. You don't have to reconfigure them every single time. You just create a profile and you're good. Once you got the settings all good and you've sliced it up and everything, you save this sliced model to your SD card. And I've got a USB to SD card adapter right here that I like to use. You do that, and then you take the SD card out, or maybe it's different from other printers, and you pop it into your control box. And then your control box, you just say, oh, I want to print this. You typically go through the menus they have and hit print whatever you're printing. The control box is just the brain of the 3D printer. It has the entire interface for what you're doing. It's what you can use to manually set things like temperatures, and also make sure it's running at the correct speed, and just monitor what's going on. It's It's just the brain of the 3D printer. So now we're going to be talking about why I got this 3D printer. There were two main 3D printers I had my eyes on. There was the CR10S and the Prusa i3 MK2. Those were the two 3D printers that I thought were the best to get and would be the best bang for my buck. And there were some pros and cons. Like, for instance, the Prusa was extremely good quality. One of the highest quality budget 3D printers out there. It also was just generally, you had to do a lot less work. You generally would have to just sort of hit go and it would be good. It also has much higher temperatures it can reach. So with a lot of these different kinds of filaments, the only limiting factor is the temperature you have to get it up to. So with this, you have to get it to a pretty low temperature of about 200 degrees Celsius. This can handle it. With other ones, they have to get up to like 260 degrees Celsius, which this might have a little bit more trouble with. The Prusa could go really high. I don't remember the exact amount it could go, but it could go much higher than this, and you can print way more materials, and it's just a lot better in that aspect. But it also has a much smaller space to print in. So let's say, yeah, this is my, I think it's like roughly a foot by foot printing space. That might be a little off. I think it would be better to say 300 millimeters by 300 millimeter print space. The Prusa, I think, has like 200 by 200. That's much smaller. It's also, whether or not you look at this as a pro or a con, the Prusa was the flagship 3D printer. It's sort of the iPhone of 3D printers, at least according to what I found online. The CR10, on the other hand, makes you do a lot more of the work and has a much higher failure rate for 3D prints. That's at least what I found on the internet. I mean, of course, if you got like perfect settings and you didn't care about speed and stuff like that, I'm sure you could probably get 100% of the time every time it works. But I just found a lot more people saying they had some sort of failures. They would have a lot more failures consistently. I also heard that in the CR10, there was only one Z-axis motor. So that would be like the motor that makes it go up and down. So if there's only one motor on one side, this side would be able to go up, but this side would be sort of lagging behind. But I didn't hear too many problems with that. A lot of people just said, oh, you'd pretty much be fine. They didn't see much of a problem, but if you're really worried about it, then you could just get the CR10S, which is like $50 more. So I was like, all right, cool, whatever. I guess I don't have to really worry about that issue. But it was still something in the back of my mind. The CR10 also costs significantly less money. Way less money than the Prusa. I think it was like $200 less, which might not sound like a whole lot, but when you've got one printer that's like $600 and another that's $400, $200 is literally half the price of the first one. And so it also seemed like this 3D printer was really just letting me learn more about 3D printing as a whole. And so with all that taken into consideration, I came to the conclusion that this 3D printer would be a lot better. Firstly, I don't really care about the quality of my prints because I'm going to be making a lot more parts and stuff in my videos. I'm not going to be making figurines and stuff like that. So this will probably do me fine. Secondly, I would rather be able to print really large stuff because I feel like I'm going to have to print much bigger things than that print space is going to allow. And what you could do, obviously, is just 3D print like this to get the most length, but that requires you to put a ton of supports under it, and it's a whole process. And this is kind of a small thing, it's a lot smaller, but considering the comparison of the Prusa i3 MK2 to the iPhone, really also just sort of set it for me. It was like, I really, really don't like iPhones. I have a burning hatred for iPhones. So that just sort of put me over the edge. I was like, all right, you know what? This is a 3D printer. I'm not getting something that's even remotely close to an iPhone. And there was that small issue of the one Z-axis motor. So I actually found out that you can get the CR10S, which remedies that problem. It actually just adds another motor right over here, and it has a couple other great benefits, like having a much better motherboard, and it was supposed to come with a spool holder to hold your spool for when you're 3D printing, and it was also supposed to have a filament sensor. Mine had all of those things except for the filament holder, and the filament sensor really sucks. It's actually a lot less useful. It's really more of an annoyance. I wish you could just take it off, but it seems like it's part of the software. So what I did is I just took the filament sensor off and I shoved a piece of filament inside, so that way I don't have to worry about it, because it really doesn't help me that much. I don't run out of filament very often, so I just didn't use it. Oh yeah, it was also supposed to come with a strain relief, because there's like some wires over here that kind of just stay there and they need some help, but it didn't, so I just 3D printed it. But it was worth the money because that extra motor and the motherboard are really helpful. It just prevents any future issues with that, and the motherboard can just, I think it's supposed to be more efficient or something, or if you want to like modify it, it's easier. I don't know. I read online that it was worth the money. And the CR10S is sort of like the plus version of a phone. So if you've got like the S9, it's the S9 Plus. And so that's just a good way to think about it. You know, it's not a whole lot of money, and the features might not be worth it, or they might be depending on your use case. And so my general experience with this printer has been amazing, kind of. It's amazing when it works. That's how I'll put it. Because I've had a lot of problems, but every single time I do have the problem, it's something that I figure out relatively quickly. There was one really big issue that I still haven't really completely figured out, where I don't know what happened. I think it was just in the end I bed leveled it incorrectly, but I come home and this entire thing is scratched up. The 3D printer is going and it's like trying to print and it's scratching on the glass, and there's this gigantic glob of plastic that's on top of it, and it's just like consumed the entire printhead, and it's just rubbing up against the entire thing. And these bed leveling knobs that are supposed to be lightly adjusted in order to make sure all sides are correctly up and down, they were completely off. So it was like this part would just be floating upward. It was a nightmare, and I had to actually replace one of the fans on here because the plastic got inside and gunked it up, and it was really a big process. But in the I actually did learn a lot of things from it too. Like, firstly, that the fan in here and the whole wiring is not nearly as complex as I thought it was, because I ended up replacing it without having to do any soldering. I just used some, I don't know what you call these things, but they're like cable connectors. It's not really special. And then when it was all said and done, I zip tied all that stuff back on so it would stay together, and it sucked because it stopped my printer from working for like a week. In the end, I did learn a lot from it, and I feel like now I could probably fix this entire thing with my eyes closed, or probably fix this thing with my hands tied behind, nope, because I need my hands in the dark, nope, because I need to see it. If somebody punched me in the face and I like passed out and then I woke up, I could probably fix it then, because I guess that's the best expression I can come up with. And so once you get that all figured out, once you're out of the sort of not working stage with this thing, and it has really good consistent prints, it's phenomenal. It's great. Oh, I almost forgot. So one thing I did find with a lot of reviews is everybody was like, oh yeah, it's super simple to build, super easy, you won't have any trouble, it's gonna be fine. Maybe it's just because I'm stupid, but like, I had an extremely difficult process with building this thing. It took me like 5 hours. Most people are like, oh yeah, it took you like 15 minutes maybe. It was a lot of heartache and pain and tears, and I had to like, midway through it, I had to like give up and relax and just sort of like simmer down, because I was really, really angry. So firstly what happened was, there's these little motors here, and the way these motors works is there's like 2 parts to it that can come off and up each other, and I couldn't figure out how to get that working originally, and then I had to look up all these videos on how to fix it. And then like a lot of the screws and stuff weren't like as tight as they should be, and so I had to fix that. And like these rods were unadjusted, and like one was super high, and it was just, and I tried looking for something to tell me how you're supposed to put all these wires and stuff in correctly, and eventually I found something good. I don't remember exactly what it was, but there was like not too many resources on the internet, or they weren't super clear. But it's probably just because I'm really not that smart. Yeah, but I've got nothing else to say except for life's an experiment, and you are the scientist. Thanks for watching. Bye.